Golden Iris Productions presents Townsend Brown and the Electrogravitic Equation by Mark F. Dennis, Electrogravitics. Welcome to the channel. Today we are diving into one of the most fascinating frontiers in theoretical physics, the idea that gravity may not be a fundamental force, but instead an emergent effect produced by variations in the vacuum permittivity of space, the same quantity that governs electromagnetism. This line of thinking traces back nearly a century to the controversial and visionary researcher Thomas Townsend Brown, who proposed that electric fields and gravity might be deeply interconnected. Today, we'll walk through the historical roots of electrogravitics, then develop a modern quantitative framework showing how gravitational acceleration can arise from changes in local permittivity, and how manipulating this permittivity could enable artificial gravity, anti-gravity, and even inertia neutralization. Townsend Brown and the birth of electrogravitics. In the 1920s and 1930s, Townsend Brown conducted experiments with asymmetric capacitors, devices that appeared to produce thrust when high voltage was applied. While mainstream physics attributed the effect to ion wind, Brown believed he had uncovered something far deeper, a coupling between electric fields, mass, and gravity. Brown argued that high electric potentials could distort spacetime, mass could be affected by electromagnetic fields, and propulsion might be achieved through direct interaction with gravity itself. Although his ideas never entered mainstream physics, they sparked decades of interest in electrogravitics, and their spirit survives today in modern attempts to unify electromagnetism and gravitation. But to move from speculation to theory, we need mathematics, and that's where the modern approach begins. Recasting gravity in electromagnetic terms. Let's start with a radical but elegant assumption. Gravity arises from changes in vacuum parameters, specifically permittivity. If the vacuum's ability to permit electric field lines changes even slightly, this shift acts like a curvature of spacetime, producing what we interpret as gravitational acceleration. This lets us rewrite gravity without mass or curvature, but instead in terms of a ratio of permittivities. And that brings us to the central electrogravitic field equation. This equation tells us, if the local permittivity equals the vacuum value, no gravity. If local permittivity slightly differs, gravitational acceleration emerges. If we engineer permittivity, we engineer gravity. This matches the spirit of Townsend Brown, but now with a rigorous quantitative foundation. Implications of the field equation. In this view, gravity is no longer curvature from mass alone. It becomes a gradient in the electromagnetic properties of space. If permittivity can be controlled, then entirely new possibilities emerge: artificial gravity, gravitational shielding, and even anti-gravity effects. This aligns closely with Townsend Brown's original intuition. Reconstructing the gravitational constant. The theory goes further. It shows that the gravitational constant can be built from electromagnetic quantities. This includes fundamental constants associated with the vacuum and charge. The implication is profound. Gravity may not be fundamental at all, but instead a derived property of the electromagnetic vacuum. Electromagnetic origin of G. This reveals a deep connection between electromagnetism and gravity. Gravity appears as a secondary effect, emerging from underlying field structure. The framework provides a consistent mechanism, scaling behavior, and a direct link to vacuum physics. Engineering gravity. If gravity depends on the ratio between vacuum and local permittivity, then controlling that ratio means controlling gravity itself. This opens the door to artificial gravity fields, reduction or reversal of gravitational effects, and engineered field gradients for propulsion. Inertial neutralization. If inertia is also tied to the electromagnetic properties of space, then modifying the vacuum locally could reduce inertial resistance. The result would be extraordinary, extreme acceleration without g-forces, motion that behaves like free fall in any direction, and high-speed propulsion with minimal energy cost, a potential pathway to inertia-free aerospace systems. Conclusion. Townsend Brown introduced the idea that gravity could be electromagnetic in origin. Modern theoretical approaches add structure to that idea, providing equations, mechanisms, and a connection to vacuum physics. If permittivity can be engineered, then gravity itself may be engineered. And with that, new possibilities in propulsion and physics begin to emerge. Why materials change permittivity? In ordinary materials like glass or quartz, light slows down. This happens because electrons respond to electromagnetic fields, increasing the effective permittivity. Higher permittivity means lower light speed. This shows that electromagnetic properties can be altered by structure. Vacuum permittivity and EM fields. In empty space, permittivity is usually treated as constant, but quantum theory tells us the vacuum is not truly empty. Strong electromagnetic fields can polarize the vacuum itself. This leads to measurable effects, such as vacuum birongenescence and photon interactions. Electrogravitic interpretation. Within this framework, gravity is directly tied to changes in permittivity. If the local value increases, we observe normal gravitational attraction. If it decreases, repulsive effects may appear. And if the field becomes uniform, inertia itself may be reduced. Engineering changes to permittivity. Several possible methods could influence local permittivity. High-energy electromagnetic cavities, engineered metamaterials, intense laser fields, and controlled vacuum geometries. The idea is simple but powerful. Control the electromagnetic structure of space, and you control gravity.